see it?
Yes.
Okay, perfect. Yeah, thank you for the introduction. Yeah, my name is David Küstner. I'm the CEO and also one of the co-founders from Synergeticon. We're a company right now operating for 9 years, so you could tell it a late startup or yeah, semi-sized company. We started in the aviation industry, doing some automotive, but I'll tell you later about more details. In general, we develop cognitive solutions for shop floor environments in the aerospace industry. And what this means, I also show you very clearly in this presentation. But first, I want to show you where we're located and who we are. So we are right now a company of 30 people operating in the ZL Tech Center in Hamburg, northern part of Germany, very close to the aviation site. So we are located in this research facility. It's called the ZL Tech Center. This is an applied research facility for aerospace technology and production. And yeah, here we can really develop system without interrupting the production. So we do pre-industrial developments, and when it has a certain TRL, we're gonna push it to the factories, and then we are able to, yeah, basically work in an EASA certified environment within the production. We come from the Airbus environment, so we started in this, but we acquired more and more customers also in the automotive industry on the way. But like you said, we have a very strong research focus because developing AI systems is really difficult, especially in high regulated industries like the aerospace industry. So we have partnerships with research facilities, also very strong with the TUHH when it comes to the acquisition of new members in the company, but also specific organizations that help within the automation domain and AI domain to really push the research forward in this way. We're also investing a lot into research, so it's 40%. Roughly 40% goes back into the research. And so we focus strongly on being the top edge technology way. So we founded 2015 in Aachen, that was the western part of Germany. And we got accepted by Airbus BizLab. Airbus BizLab was the first accelerator of the Airbus accelerator program in 2016. We won this program, so we were able to move into the ZL Tech Center. You also, I think some of you also visiting today to look at the facility. We then joined as an Airbus partner in 2018. It takes actually a long time as a startup to enter such a regulated environment. Yeah, it's not made for startups. It's coming slowly, step by step. But since it's so high regulated and so locked up basically as an industry, it takes a lot of time to really be established in this. But then we launched our first product. I'll also show you later in the slides. It's a hall monitoring system for assistance that actually monitors everything that's happening in the factory hall and digitalize all the data that are happening. We then joined the XLR program, that stands for extra long range. This is a new Airbus project that's actually replacing some parts of the A320, puts for a higher range. So now you can just fly from Europe to the US with A320. That was not possible before because of range limitation. It's now possible, so it's one of the newest products. Then in Corona, it forced us to also go into the automotive industry. So we did our first products there, but now we're a really big part of the industrialization in the Airbus XLR program. And also the newest thing is the Zero E program. Maybe you know, it's the hydrogen aerospace program. So they replace the kerosene with hydrogen-based systems. So we're also part of the pre-industrial line in this. So this is the story basically we went through as a company. Now we consist of highly trained experts in the field of AI, of digital technologies, everything you need for implementing these systems. But now I want to come more into some applications, like real applications we do. So you get a good understanding in which field, basically AI technology and advanced automation is needed in the field. So I have 4 different parts I want to talk about today. The first is the cognitive assistance. That's basically equipping robots with sensor technology and software, like digital twin software. And then we are able to perform different tasks like riveting, pick and place, also quality inspection. This is the next part. So we're using sensor assemblies to find, for example, cracks on surfaces, to look at quality, to see if even like the screws are tied up and so on. I mean, you remember the Boeing case some time ago, that a part of the Boeing plane fall out during flight. So we really go against this to ensure that we can do 100% quality inspection. So something like this cannot really happen. It's also in form of assistance with the human, but it ensures that we really capture all the quality data and analyze it within the process, but also show you application to this in detail. Track and trace, this was our first product, basically equipping cameras inside the factory hall and being able to locate every object in the factory hall to really see, okay, maybe a part is late, or maybe a part is put in on the wrong position. Like, there are many use cases what you can do with this, basically putting supervision to the factory floor. What's really important here is the anonymization part, because you film basically humans. So we had to make sure that we comply with all the regulations, the GDPR, and also the legal frameworks, to be able to really delete the human out of the source data. Basically, we call it ghost mode. It's basically this feature that deletes all human activities out of this. So you just see what's happening in the factory without being able to survey the human being activities. And the last part is 3D reconstruction. It's get more and more important, because more factory environments go into complete simulations or digital representations of what's happening. And what they need are really the assets in the current form. So we are able to reconstruct with our robotic systems or camera systems these assets. So you can really see if something is wrong. You can see all the cracks, you can see deformations and anything else. I'll also show you more into detail later. I put some of the use cases here. So this was a use case where we did a battery refillment. So basically these are batteries from the aerospace to operate all the systems within the airplane. So they come and they need to be refilled and also quality checked. So here you see systems like we develop. So these are very typical systems we do, where we equip sensor to robotic systems, and then they're able to find their own targets and operate like semi-automatic all parts here. So you just push the batteries to the system is working on it and actually puts the battery to to the stat that it needs, with all documentation needed. So this is very typical within aerospace, because you need very flexible systems. You have a very complex product, but you have a low throughput. That means you need a high flexibility on your systems in operating this. So this is what we implemented in combination of computer vision, automation, and also simulation environments to operate a system like this. We're also doing this for riveting. Basically, it's like a screwing process for the structure elements. So we also have a helping system that's basically helping to screw some parts on a mobile platform that can be also operated by the human being. You see the glasses here. This is also one of the projects we did. It's not so accepted because even though the glasses get lighter and lighter, it's not broadly accepted to put it on because there are problems with some people get sick, or it's just a factor that's not very comfortable to have this on the head. So we go more and more into augmented reality on the tablet, basically. Yeah. So we overlay real data with so like object data we have, and but we can show this on the tablet. I'll show you later some examples of this. We go away from the glasses on the head, more on the mobile solutions on the tablet. Here you have another system. So basically it's not robotic driven, but it's a whole quality process where we use smart tools. Basically, they're able to be controlled in real time while it's operated, because every screw you perform has to have a different kind of torque moment. Yeah. And it's coming from a digital model. It's connected to a digital model. So we are able to perform like an automated assistance that nothing can go wrong anymore, because every screw is actually checked. We have a tool tracking. So we know all the positions. And if the worker is doing a failure, the system stops automatically. So it's failure resistance in real time. And this is very useful because you can achieve 100% quality inspection while you doing the assembly and also the reporting within. So it's also a ASA certified solution we implemented within the customer. Here you see how it works. So we have position trackers, we have smart tools, we have also an assistance with a digital model that supports every step. And you can just input process data and 3D data because you have different parts, and it's very generalized. So it's not only working for this solution, it's working for generalized solution with auto calibration and so on. Yeah, in the Q&A, we can more go into the details, but I think for now, it's okay. I also showed, I have a video from the production. I show you. And so this is a production environment and shows basically the application within the production. Can you hear the music?
No, not really, but the video is working fine.
Okay. I skip a little bit because it's too long, but I think it gives you a good sense on what's doing. All right. So I think it gives you a good understanding what this is. In the Q&A, if you're interested, we can also go into a deeper dive. You can still hear me, right?
Yeah.
Okay, perfect. Okay, now I come to the quality part. So basically, when we have, so we talked about this quality before, but I want to show you an overview what the problem is basically with quality in aerospace. So I start with the latest because it's one of the most important. Wait, sorry, I go back into the mode. So if you find an error too late, it can be very, very expensive, especially when you have very expensive parts, and delays are so cost effective because the whole product is very expensive. So this is the biggest issue actually. And when you think about a business case, one of the biggest business drivers when it comes to improvement of the quality inspection within the aerospace. Also, the compliance and regulatory compliance safety is very strict in aviation. So it's different to automotive, to other industries, because you have very high standards. Basically, that actually needs the support of the quality systems to make it more efficient. Yeah. The time constraints, in aviation, you cannot just do it like in automotive, that you actually automate all the quality processes in the line, because the product is very big and complex, and you have so much variety inside, like you see here. So this is time constraining, and the variability leads to a high level of expertise. So that's why it's very good when you put automation to it, or more automation, but it must be feasible. So that's why we're building on lightweight robotic systems, basically, like you see here, where you're able to combine different kind of sensor data. So this is our new system. We have laser scanner, we have cameras, we have all different kind of sensor fusion going on here, and a live scan of the environment in a very high quality, so we can implement the robot model with the environmental data. So all the data coming from the sensor, and then we have a very easy operating system. So basically you click on the parts and you can define what the robot should do. Yeah, it's an interactive system. You see what the robot sees, you see what the robot understands, and then you're able to interactively control the robot with just clicking on the environmental items, with all automatic path planning. So we are able to actually operate in this environment in a very easy way. Yeah. Let me see. Yeah, here you see also it's automated segmentation we use for, it's an AI module that actually deploys spatial intelligence. Basically, in the scanning environment, we see what the objects are, and then with an annotation process, we can also interact very easily within this process. Just, telling the robot basically what to do. We're using this also for damage detection or surface crack detection. We can read numbers, we can identify objects, we can identify vectors of different kind of angles. So for pick and place or for automation of screwing processes is really important. And what's new, we put this all into an easy graphical programming interface. Basically, to control a robot like this and to set up all the processes, no programming is needed anymore. So you can just put the building blocks together, that you can create your application as a quality engineer on the shop floor in a very easy way, even if your parts are unknown. Yeah? Because normally you always need CAD data or some digital representation. We do scanning on the fly within the shop floor, and then we use these assets to control the robot further to perform a different task. So it's very useful, because you don't need to set up a digital twin first with all assets and so on before you even implement a robot. You can just go to the shop floor, put the button on, and basically go for it. Yeah? So we combine it with, here we have basically interactive live scanning coming in. We have computer vision AI to actually detect objects and also defects and anything. We have the mobile robotic platform, but also fine measurements. So the computer vision works together with the fine measurement. If it finds something, it goes and makes a very fine measurement, because in the aviation industry, we need actually the depths also of cracks, not only the surface description. And this can be all done with the plug and play configuration, no code platform, basically what I showed you. So what we use there is also no code for building your whole computer vision algorithm. So basically computer vision means we can detect or segment different kind of parts. We can detect it, and then we can also measure localization of where it's at when we have more than one camera. But to make it feasible that the customer can really build his own configuration, his own application, we are able to give the platform to the customer. He has any kind of computer vision use case. So maybe he wants to detect airplane parts or logistical assets or anything, yeah, basically. So he can really click his application together with his solution, also without coding. But if they want to be more specific and they have their own code, we're still able to implement this code within this building block architecture, basically. If you have questions to this, we can go in a deep dive also in the Q&A. But to give you an understanding what this is about, basically build your own application when it comes to computer vision and localization applications with a multi-mesh camera system. So this can be done with this solution. Here you see an overview how it works. So we have the training data creation. It's basically an AI-supported annotation platform. It works like Paint in videos. Basically, you click on a part, it's auto-selected. Then it creates the whole tracking in the video. So you can create your own data with this. You have the infrastructure configuration and data configuration. So you just put if you have a computer, you just put a graphical surface here, you put the features to it, and it's all auto-installed basically on as many computers you want. So they're all aligned with each other. And then you can basically create your applications like you want, with also dashboarding in the end. So we have a dashboard builder where you can actually connect all this data together. So end-to-end computer vision application. Yeah, this is being used in the tracking of different airplane parts in production, but we also use it very strongly for crack detection and defect detection, corrosion detection. We have projects where we apply it to bridges, for example, cracks of bridges and defects. So these are very range applicable. Yeah. So now I come to the 3D reconstruction. So you can see the robot when it goes and using its sensors, it can use virtual environments. Basically, I don't know if I'm streaming in real time. It looks on me in real time. Maybe I don't know how good the Zoom is transferring it, but you see we can actually create the objects from the environment. We can also overlay it with computer vision data for detection of screws, of detection of how dirty a part is, and so on. So there are different solutions we now building on the platform to being operated with this. Yeah. Here you see also another version of the robot. So we also have an outdoor kind of applicable system, or when you have cables in the way, we have different kind of AGV platforms to operate these scannings we do in the factories. Here you see another video, maybe a little bit bigger, to actually see what quality one can achieve with the reconstruction, the robotic reconstruction. Or here it's a battery module from the Volkswagen cars. Basically with this technology, we're able to construct really the essence of an asset, to also even we're able to read what's on it, or we can go down to the QR codes even. Here you see a large scale robotic system. So basically when you need a large area, it's important that you are not able to capture all the data you already need. So we use generative AI to fill the gaps in between, to really be able with like small data sets to even do large scannings of environments. Basically, this is not a video. This is basically a scan, of the environment. So we can go on every angle we want. That's basically right now for all the systems. So I go back for the overview. So what to do is summarize. So I showed you right now, how can we use cognitive assistance, basically robotic, mobile, lightweight systems to perform different kind of tasks inside the aviation industry. This is very important for quality. So also using these sensors to create quality inspection automatically. I showed you about track and trace application, basically doing the localization tracking and events tracking on the shop floor. And the last part, 3D reconstruction, that is also really important for the aerospace industry to create assets to really see, okay, to have a digital 3D documentation of the status of the part, basically. Yeah, thanks a lot. So we come now to the Q&A. We have 50 minutes left, so you can ask any questions you want, and we can go also deeper in the topics if you want. Thank you.
Yeah, thank you, David. That was quite interesting and a lot of information to digest. So first of all, I'm going to open it up to the floor here because I do not see any open questions on the Zoom right now. So are there any questions here in the thing? Yeah.
Thank you so much. It's Yuri from Ternopil. Well, I often quote that future is already here, but it is not equally distributed, and now we see where it is based. So my question, again, I will quote you this time. You said, quote, nothing can go wrong anymore. Everything is AI controlled, end of quote. And what about controlling the artificial intelligence? I mean, the EU Artificial Intelligence Act, which is entering into force. And
yeah, this is a really good question. Oh, sorry, I'll let you finish first with the question.
So you understand my question, I suppose.
Yeah.
Do you
Right.
say it does help or hinder your developments?
So first, I don't know if I said everything is AI controlled. Everything is basically controlled. We have a 100% quality inspection. So AI is helping, but you're totally right. Who is controlling the AI? Because AI is known to also make failures. And especially in aviation, this is a big issue. Yeah. So what we're doing, we combine AI systems with classical monitoring systems, basically as to be an enabler to gather more information. But then you have a big difference in the requirements, and this comes with the use case. When you have monitoring of the factory hall where you track your parts, it's not that bad if your system makes a failure in 1 second, because in the next second it sees it. So it's also not really safety because it's just an efficient topic, yeah. But when you detect cracks, for example, or surface defects, this is a big issue because when you do a wrong measurement, this is a problem. So we're working very closely with agencies that support this. With our customers itself, they have internal programs where they look at this. So how can we create AI-based systems that are EASA certified? Yeah. And really look at the different use case requirements and see, okay, where do we have to apply and how do we have to apply AI to the systems that we are safe in the end? Yeah. So, but there are also European organizations and also German organizations. They have this on the table. They have working groups to discuss about this. But we're seeing that this is really, really use case related, and it can differ strongly with just one variation in the use case. So that's why it's so difficult, because you can only answer this when you really have deep know-how within the use case and the technical parts. Because one technical change could lead to a whole different analysis. Yeah? So what we're doing, we implement AI-based systems. We talk to EASA about it, and also we show what's possible. And then on what's possible, we discuss, okay, how we go forward and how we make the systems better and more visible, basically. Yeah? I give an example. So I showed you this robotic systems where we identify different defects with computer vision. And then we go closer and we measure very fine measurements. Yeah. So this is an application that only uses AI very partly, only for the point of interest detection. But it measures the part in the end with a certified module that would be used by a human anyway when they're doing it the old way, basically. Yeah? So these are the use cases where we really have to specifically see what are the requirements, also on the quality assurance part. And so we are able to go through certification. Yeah? But we're still on the way. So we didn't put everything what I showed today into production. Some of them is in production already. But some AI systems are right now in the phase of POC and also very deeply consideration from the EASA. Yeah, I hope I could answer your question.
Yes, yes, thank you so much.
Okay, there are other questions here in the plenum. Doesn't seem to be the case. Then maybe I've got one more question. So it was quite interesting when you showed the project with virtual reality or augmented reality, and then stated that yeah, it goes more or less now in the direction of using tablets again. So at least in my opinion, that is kind of a back step from current technology. So why is that the case? Is an AR headset too invasive in a production environment, or?
Exactly. So the technology is still developing in a way that can be used in a very easy way. So one of the points is the setup is still too heavy. But the problem, if you use LiDAR system, you cannot really show the whole resolution of what's possible. I mean, when you think about what Apple is doing with the Vision Pro, this is actually where it should go, yeah. But I think it will go into this direction. But so far, we have these problems that it makes people sick. This is one big thing. So they cannot wear it for 1 hour. And it's always good for showing demonstrations. So you see it on every exhibition, basically. But when you go to the shop floor in the factory halls, how often did you see people wearing these headsets while they're working in very industrial environments? I haven't seen a lot. So they all come to a POC status, and then they fail because there's not this acceptance from the workforce. But I would say that it will not go into this way, because this technology is also improving a lot. But since we have the core technology that's working really well and is not too heavy, basically, I think it will not be accepted. So this is our finding from all the research we did. But I think it will go into this direction when the core technology, the glasses basically get better and better. And with eye tracking, I think you can now do also a lot to avoid the sickness. Yeah. Yeah, but this is basically my statement.
Yeah, cool. Thank you very much. That was really quite interesting. So I saw that there is another question. Yeah, there is another question.
Sorry, it's again Yuri from Ternopil. That was not a question, but rather a comment, because in Ternopil, of course, our achievements are much more modest, but we had the same problem and the same solution. What works with windshields and tablets may not work with hand-mounted displays. And that's the difference between Industry 4.0 and Industry 5.0. You should put the human into the equation. So some solutions which had been acceptable for Industry 4.0 will not work in this case. So there's lots of particularities to discuss, but really that's the trend. Thank you.
Okay.
Yeah, thank you. Yeah, I've maybe also one comment to this. So there are some alternatives to the glasses. So you see the tablet where you actually put augmented feature inside, but the next step is to using projectors or laser-based projecting systems that you see the solution right at the part. Yeah, there are some vendors that they do this. They're basically projecting just the things on the real part without you having to wear a tablet. There are disadvantages about it, because it's very expensive technology, and when you actually want to equip the whole factory hall, it's very expensive. But on the other hand, you don't have to wear glasses. Yeah, there are many solutions, but there's not this universal solution so far that really works for every case. Yeah, but I think the technology will improve, and it will come one day. Yeah, so.
Okay.